I'm going to talk about navigating quantum readiness journey, and also a little bit about quantum safe cryptography and how Keyfactor solution can help in this area. My name is Tony Chen. I am solution engineer from Keyfactor for APJ region. So let's dive into the topic. All right, so the news is here. The industry has been waiting for so long, and finally, NIST announced the first three post quantum algorithms, and to protect against the threat of quantum computers. So we have now dilithium has been standardized in MLDSA. That's digital signing algorithms labeled as FIPS 204. And we also have Kyber, standardized as MLKEM, which stands for Module Lattice-Based Key Encapsulation Mechanism, labeled as FIPS 203. And also Sphinx Plus now has been standardized as stateless hash-based digital signing algorithms, FIPS 205. So why the release of post-quantum algorithms from NIST is so important and exciting? That's because, when quantum computers are capable enough, it poses a new threat to today's cryptographic, largely on public key algorithms, which also means the internet, the TLS connection, the digital signatures that we're using today for software signing, firmware signing, SBOM signing, as well as PKI and blockchain, will be 100% vulnerable to quantum computers, right? And now with NIST standardized algorithms, it's really exciting, and it's a kind of starting point for every organizations, not just to thinking about the future, but also at the point where you can start incorporating into your test environment and work towards production environments in your business, your products, your infrastructures, everything. So what can quantum computers can do, right? So if you look at the table here, we have public key algorithms such as RSA and ECC. They are really vulnerable, and the security level of RSA and ECC will drop to 0 immediately, regardless of key size. While for AES symmetric keys, they are still okay. They are less impactful and will stay strong because the security level will down to half, but we can always increase the key size to mitigate the threat there. So really, there's a huge impact on public key algorithms and all its use cases. So that should be our focus here. So the story here is really quantum computers are developing in its exponential speed with all the technologies and AIs. And we know that quantum is coming, right? And we've seen companies like Google and Microsoft, governments, they are actually taking actions to address this new threat. All the standards coming out and all the advisories and so on. Pose a new threat, new risks to the entire internet, critical infrastructures, applications, whoever relying on public key algorithms, they should recognize this new threat here. Now we have the standardized algorithms is here, and what should we do? And we think it's time to prepare now for two reasons. The first reason is this is going to be a long migration process, right? We have 3 standardized algorithms, but there will be more coming. So currently, NIST is looking at 14 candidates just to add more diversities in terms of the mathematical problems underneath. So we have module lattice. They're adding more different mathematical problems just to, adding more diversity there. And we learned from the experience from migrating SHA-1 to SHA-2, right? It took roughly a decade, right? We know that there's a lot of work a lot of testings, evaluations need to be done. And personally, I think even for legacy SHA-1 or today we have classic cryptographic, there will be still some legacy systems that cannot support PQC, post quantum cryptography forever. That's the fact. And the second reason is harvest now, decrypt later attack. That's happening right now, right? With all this, the earlier the organizations prepare this PQC migration, the better for the organizations from risk mitigation perspective and also business continuity perspective. That would be very important. So before we talk about any planning and preparation, it's good to understand what's the difference between classic algorithms and post-quantum algorithms. So in general, we have SLH DSA and ML DSA, those signing algorithms. They'll be working the same as what we have right now, but with bigger key size, bigger signatures, which also means they have greater demand in terms of storage space, memories, and CPUs. In terms of key exchange, so PQC, we use key encapsulation mechanism. This works a little bit different from what we used to have, Diffie-Hellman and all these algorithms. So that will require the underlying protocols to be updated as well when it comes to key exchange. And if you look at the performance level, we have done a testing. We use RSA 3000 as a benchmark. And we found out that ML DSA, which is previously DDFM, is actually 30% to 20% slower than our benchmark. So this is a pure soft level testing. We haven't put into considerations of all the hardwares, all the infrastructures, and application level stack. Right, so the standardized algorithms are here and really triggers a lot of chain reactions of changes. So we used to have all the protocols. Now we need to update the protocols, the formats, the RFCs, TOS standards, PK611 as well, and we need to update them. And also for hardware devices, HSM, hardware security module, trusted platform modules, secure elements. We need to update the standard to support the standardized PQC, and we will also expect the same FIPS certifications on those hardwares. Any products that communicate security on the network or use cryptographic, their libraries need to be updated. They need to support PQC as well. That's what we're saying. Google and Cloudflare, they are using standardized MLKM in their secure connections as well. For most of the enterprise, we think inventory is the key. To have inventory of all your algorithms, all your certificates, all your keys, and prepare for the migration is the key for most of the enterprise, who is consuming all the solutions, all the products, all the devices. And if you look at the timeline here, so previously we have our friends here presented the same as well. Basically, for software firmwares, we have to preferably to be supported by 2026, and is required by latest 2030 for almost every devices. That's including the PKI, the operating system, the web browsers, software firmware signings as well. That's the date here. And specifically for PKI migration strategy, it is clear that PKI migrations in general is a very challenging task, and due to the long-term certificate runtime or the root CAs, so we should expect this long-time migration process there. So it's therefore important to plan and to initiate the migrations in the early stage in order to be able to implement the changeover to post-quantum cryptographic in time and with necessary business continuity. So we have 4 strategies here. The first one is complete migration. Basically, you switch directly from your classic PKI to quantum safe PKI. And the second and third, we saw a lot of governments come up their own plans. So in Germany, they've been proposing this transitional migration plan. So basically, they have classic PKI and post-quantum safe PKI running at the same time and slowly phase out the classic PKI infrastructure. We've seen also hybrid strategy. So basically, you set up a hybrid PKI, hybrid CA that can issue hybrid certificates that will help you to be able to support your backward compatibility of your legacy system and also to support the post-quantum algorithms. Composite, this is a little bit complex topic. Basically, they have they basically merge the classic PKI and post-quantum PKI into one certificates, and these strategies basically is to switch directly from legacy classic PKI to composite PKI. So our recommendations from Keyfactor, that's why we have this T-shirt today. This guy his name is David Hook. He runs open source crypto library called Bouncy Castle. Anyone heard about Bouncy Castle? Yes, here you go. So we suggest to start now, start today, and start to establish responsibilities. Who should take care, this PQC topic? Do we have a team in our own organization to look into, testing, evaluating the PQCs and also oversee the migration implementation? Get an inventory of your use cases and identify the risks associated with your use cases. I think this is critical to understand where you are exposed to, where's your risk, and also get an inventory of algorithms and keys and the certificates, and map that data to your data classification, right? So you have the link from your keys and what the keys are protecting your critical data or confidential data in your organization. And of course, plan the changeover for the algorithms. For manufacturers specifically, post-quantum firmware signing is a must, right? So this, I'm also thinking that SBOM signing should take a PQC signing into consideration as well. And crypto agility and updatability are important, as in how the system are designed to be able to update cryptographic algorithms, keys, certificates, device identities, and redistribute your new root of trust in a massive scale, as well as methods to respond new vulnerabilities or standards, and to stay ahead of threats and maintaining the data security across changing cryptographic landscape. So with Keyfactor, we have the full suite of quantum-ready solutions, from inventory of your algorithms, keys, certificates, or today a lot of people call it cryptographic bomb, C-bomb in general, right? To our bouncy castle, someone knows bouncy castle as well as open source crypto libraries. We also support all full suites of post-quantum algorithms there. They are open source. eGBC sign server, they are open source as well. And today you can use eGBC to create quantum PKI, quantum CA, and issue post-quantum certificates and also hybrid certificates. Sign server, you can use sign server for co-signing, start co-signing today using post-quantum certificates. By the way, anyone here knows about eGBC and sign server? Just a heads up. Thanks. All right, so the three products in the middle, they're open source. Command, unfortunately, today they're not open source. They have enterprise support. But eGBC sign server, as a product, we do have enterprise level product as well. And with Command, that's your crypto agility platform to integrate with your devices, your web server, your operating system, your devices, your load balancers, your firewalls, to be able to support that algorithm certificate changeover in this scale level. And also, we have, for anyone who like to learn and explore and prepare for PQC, Keyfactor also give out our PQC lab. So maybe I'll just pause for a second. You can take a photo for that QR code, and you can access our PQC lab, which is a sandbox environment for testing as well. All right, that's all I have today. Thanks for everyone, and thanks OpenSSF for the opportunity. Thank you.